In this video, we'll look at seasonal forecasting. For seasonal forecasting, we need to have complete cycles forecast. For example, if the seasons are months and variations of months are known, we need to have complete years so that we are able to calculate seasonal index for each season. Here we have 3 years of data. These are the number of units sold per month. The first step here is to find out which one of those months for each year are more than or less than the average of the year. So the average of the year is the baseline, and then based on that, based on the ratio of the sales of the month, we determine the seasonal index for each month. So average of the year for each year, and then the ratio of the month over the average. That will be the seasonal index. For example, for seasonal index of the first year, January is about 91% of the average. Same way, we have the seasonal index for all months. The sum of seasonal indices of a complete cycle should be equal to the count of periods of the cycle. So if I add up all the seasonal indices for a year, they should add up to 12. The same way we calculate seasonal indices for every month of the next 2 years. Now, seasonal index, overall seasonal index for each month is the average of seasonal index for all years that month. We calculate the average for each month for the 3 numbers we have, and then we have the overall seasonal index for each month. Next step is to deseasonalize the data. Take out the effect of seasons so that we can have a smooth data set without the effect of the seasons. For each month of the year, divide sales that month by the overall seasonal index. Now I have deseasonalized data for 3 years. That's a sequence of 36 months. We can use any forecasting method to do the forecast for the next year. If there is a trend, we can use regression analysis to find out what's the demand for the next 12 months, and then adjust that demand using seasonal index. So the first step, I will put all these numbers together in one column, prepare them for regression analysis. Selecting and copying. Since these are formulas, I will do a paste special by right-clicking paste special and just pasting the values. You can get rid of the formulas. Put the numbers in one column. And these are sales. We do have month. So independent variable will be month and dependent variable sales. Start from month 1 all the way through month 36. I'm using Excel Data Analysis Toolpack for regression analysis. Input Y and X ranges. Y is sales, and X is months. Labels are selected, so I check them. Output range, I will put it somewhere here in this worksheet. And click OK. You can see R square 51% of the variations of sales are explained by month. Two important numbers, intercept and month. Intercept is the constant value of the equation, and month is the coefficient of the month. So our equation will be y equals 85.44 plus 0.46x, and x will be the month. Now the numbers for next year, I will directly reference these two numbers. We'll continue months up to 48, 12 additional months, and here I enter the formula. My first reference is to the intercept, which is of course an absolute, plus reference to month coefficient, absolute, times the month counter, the same row. And we'll continue for all 12 months. These are the numbers for next year based on deseasonalized data. We will adjust them using seasonal index. So I will copy this, and one more time do a paste special, since those are formulas, just the values. To adjust using the seasonal index, overall seasonal index, for deseasonalizing we did divide the numbers by seasonal index. Now we will multiply these numbers by seasonal index. So each number times the overall seasonal index. And these are the forecasts for the 12 months of the next year. And that's the way to separate the seasonal variation from any other trend that exists in data. We take out the effect of the season, do our forecast with the method that is appropriate for the data, and then adjust back the values based on the seasonal indices.